Welcome back to my channel. Today I'm discussing about the numericals of viscosity. Before going to the viscosity, we need to know formulas of a viscosity. We know that coefficient of a viscosity, in some of the books they have mentioned it as a V, or it can be taken as eta also. V or eta both are same, that is coefficient of viscosity. So which is equal to pi p r is to 4 divided by 8 VL. So we know that P is the pressure of that liquid, R is the radius of cross section of that tube, and along with that V is the volume per second, or a volume, simply we say take it as a volume. L is the length of that narrow tube, or you can take a capillary, whatever they have given. Okay, so Stokes law. Okay, so that force exerting is F is equal to 6 pi eta VR. So eta stands for the your coefficient of viscosity, V for the velocity, R for the radius. Okay, this derivation is did from the using a dimensional formula. So if I want a terminal velocity, I can use a 2 by 9. Okay, 2 by 9 r square g. Okay, this is acceleration due to gravity eta into rho minus rho dash. So we know that rho stands for the density of a steel ball. Okay, so rho dash stands for the density of a liquid. So r is a radius. So if I want the coefficient of viscosity of a liquid, how to write that? So just take a Vt to the denominator and eta to the LHS of your equation. So that will be eta is equals to 2 by 9 r square g upon Vt into rho minus rho dash. So if I want a viscous force, okay. So how to how to find the viscous force? We have the expression which we used in our derivation, that is Pauli's formula. In that derivation for an arrow tube we took this. Okay, F is equal to minus eta a du by dx. So this minus sign stands here. So the pressure or the force exerted by outer layer or outer molecules to the inner molecules, that whatever the flow is opposing. Okay, the outer force and the flow of a liquid both are in opposite to each other. So for that sake we have written the minus. So if I want it u instead of u, if you want to take it as a v, you can take F is equals to minus eta a dv by dx. So this dv is a small velocity, small change in velocity, and dx is small change in displacement. Fine. Analyze the problem. So the key points whatever we need to understand in this problem, we'll see now how to analyze the problem. So we are discussing the numericals of a viscosity. Okay, so first question is, the water is flowing steadily through a capillary tube of length 0.25 meter and radius 1.22 millimeter under a pressure head of a 0.2 meter. So if 45 into 10 to the power of minus 4 meter cube of a water is flowing through the capillary tube in a time of 12 minutes, then calculate the coefficient of viscosity of a water. This is the question. So we need to first, what we need to do? We need to analyze the question. So whatever they have given and what they are expecting from us. Okay, we need to understand this. So what they said, they said that one capillary tube is there. Its length is around 0.25 meter. Okay, so if we take this as a capillary tube, its length is around 0.25 meter. Then what they said, and radius. So if you take this cross sectional area, so this is the radius. Okay, that radius is 0.2 meter. If 45 into 10 to the power of minus 4 meter cube of water is flowing through the capillary tube. So what it means? So this is the volume. Okay, so this quantity is your volume, because see, if you're not understanding what is this, observe the SI unit. Okay, so if you're not getting, then you observe this SI unit, you get to know. So volume, it is measured in metric cube. Okay, so this 45 into 10 to the power of minus 4 is the volume of a liquid which is flowing inside this narrow tube or a capillary tube. Okay, so after that what they have given, so they have mentioned the time, at what time it is flowing, at 12 minutes that liquid is covering this capillary tube, that flowing in through this capillary tube. Fine. Then calculate the coefficient of viscosity of a water. So what we have to do, we need to find the coefficient of viscosity of that water. So we know that coefficient of viscosity of a coefficient of viscosity is eta is equal to, so observe whatever they have given. So we have a two formulas, right? So that is pi p r is to 4 divided by 8 vl. This is one formula. Okay, another formula also we have that is also coefficient of viscosity, that is 2 by r 2 by 9 r square g divided by, okay, eta into rho minus rho dash. So before applying the formula, we need to think or we need to observe whatever things are given in my question. So what are the things they have given? They have mentioned length. Okay, one is over, and along with they have mentioned the radius. One is another thing is over, and also they have mentioned the volume. Good, that is also over, and we need to find out the pressure. That's it. If I find out the pressure, I may find this coefficient of viscosity. So this formula is much more fitting to the this problem. If you see this, okay, I don't have problem with radius, that I know the excitation due to gravity, but what I don't know this quantity. Fine, so I don't know, so sorry, I don't know terminal velocity, I know only eta value. So how to know? So that too from this formula. So this formula not suits, this formula not suits. Okay, so the thing is this formula suits over here. So we got to know that this is the exact formula we have to put or we need to find. So write down the given. So what is the given? Length of the capillary tube is 0.25 meter and time they have given 12 minutes, and radius of a capillary tube is r is equal to 1.2 into 10 to the power of minus 3 meter. So how to find out the pressure? So we know that pressure is equal to, so whatever you are no. So sorry, if I take this as a container, if I insert a capillary tube, okay, if I insert a capillary tube, so I am taking the density of that liquid along with that excitation due to gravity and how much water is increased in this capillary tube, that is h. Okay, height of that capillary tube. So whatever rise in the liquid, that height I am taking h. Okay, so that height whatever I am is there, no, so that, okay, so that they have given here. See, under a pressure of head of 0.2 mm 2 meter, so that is your height, this is your height. Fine, so we know that the density of water is 1000. Okay, so density of water is 1000. So substitute that thing, density of water is 1000 into 9.8 into 0.2, that is the height of that liquid. So height of that water raised in a capillary tube. Okay, so if you solve this, you get a 1960, means 1960 Newton per meter square. This is your pressure. I think you got the pressure. So just substitute this pressure into your main formula, then you get the answer. So before going to that, they have given you the, so under a time of 12 minutes, we need to find out the volume per second. Fine, so we need to find the volume per second. So to convert this volume per second, what we have to do? So how to convert that? So to convert that, we need to just multiply 12 into 60, whatever you have now. So you have a 12 minute of time. So for this 12 minute of time, just multiply 60. Okay, so you will convert into the second. Then do this calculation and you get a 0.0625 10 to the power of minus 4 meter cube as the volume of your volume per second, volume of water flowing per second we found. Okay, so lastly we need to find out the coefficient of viscosity. Eta is equals to pi p r is to 4 divided by 8 vl. Substitute all the things. So pi value is 3.142 into, so we found the pressure, that is 1960, okay, into, so radius already we know from the given. So they have given you the radius, that we substituted. So that radius we have substituted here 8 as it is. So volume we found here, volume per second, that I have substituted, and length also they have given, that is a 0.25 meter. So just solve it, you get this answer. So I need it into the 10 to the power of minus 3. So I shifted this point to over here. Okay, you got a 1.02178 into 10 to the power of minus 3 Newton meters per meter square second. Fine. I hope you understand. Thanks for watching.